Hello.
Hi, Hari.
Folks. Hey, Ashton. Nice
How are you?
conversation. It's really good. Awesome.
So thank you. First of all,
Perfect.
thank you for supporting our ecosystem. We are also privileged to be part of the NVIDIA Inception program. So thank you for the support from your side.
That's awesome. And I really love working with OpenMesh. So the journey of OpenMesh is really great to see. I see Xmode shaping up very well, and you're integrating with multiple AI fraternity and making things easy for the Web3 world. That's cool. Yeah.
Thank you. So I'll pass it to you. You can share your screen. Thank you.
Awesome. Great. Hope my screen is visible. Right. So today I'm going to talk about what NVIDIA is doing in the generative AI and agentic AI world. Uh, that's going to be my core presentation today. So uh, before getting into the details and specifics, just want to mention most of the people will think that NVIDIA is a hardware company, but to put it righteously, it's more a software company rather than a hardware company. uh, we we build a lot of open source solutions. We contribute to massive open source toolings in the ecosystem to get things out fast and quick to the GenAI fraternity. Right. So let's jump in what we have built with GenAI. So to understand NVIDIA's depth with software, I just want to show you this stack. So if you see the bottom of the stack, you can see the hardware, which is basically all GPUs, TPUs, as well as we are building CPU. So all those hardware will lie at the bottom, which is consumable through a data center or through cloud, hyperscalers, or through NVIDIA cloud partners, or at edge. Uh, on top, there is a common layer like what we built through CUDA. So on this, then we also started building CUDA X libraries. So what we mean by that is, so we don't want every developer to sweat it out, write very specific application logics on top of CUDA. So we have multiple different ecosystem work, something like you have data processing related work, you can do automotive related applications, you have quantum related work, weather forecasting, or generative AI, agentic AI. So all these stacks need a very different mechanism to build solution stack on top of GPU and CPU. So with this CUDA X libraries, we are trying to accelerate the total consumption with simplistic APIs, which is built on top of Python, C++, or Rust. So it can be more API specific, and you can write less boilerplate code and directly get into the specifics of using GPU effectively. Right. So this dots, what you're seeing in the graph, is the number of packages what we got in the NVIDIA's universe of software ecosystem. So we have around 4,000 plus software packages, and we have multiple numerous frameworks, application frameworks, which can accelerate specific industrial verticals. So this graph represents the foundation layer, which can speed up data processing, which can optimize and deploy generative AI solution stacks. All the dots are the unique softwares, and the lines are the dependencies which are associated with it. So we have 4,000 plus unique software packages when we put that out in a graph. Right. Let's now talk about GenAI, which is very hot topic for the past couple of years. What we are seeing now is GenAI is not only going to be just text. We are seeing multiple different forms of input. We are seeing even brainwaves, amino acids, multimodality, speech, text. All this kinds of different information is fed through the models. Then the decoders can perform efficient, and it can give us very unique information out of what we want to learn from the data. Then most of the organizations nowadays are like having like three stages of adoption of generative AI as well as agentic AI. The first one is like less customization. So you have a chat GPT OpenAI endpoint or a reasoning model endpoint, which is directly customized, which is directly integrated within the downstream applications. Then the next level, what we're seeing is for advanced use cases, like we are seeing a bit of fine tuning in their own business data. Then the third level is extensive customization or even like training models from scratch. So these are the three layers like what we usually see. Uh, so if you see, if you put that in perspective in a workflow, these are the different stages like we broadly like see, which are data preparation stages, training and customization stages, and consumption or deployment stages. Uh, I'll be talking about this in specifics going forward. So let's now talk about inference first before going into fine tuning or customization of generative AI models. So predominantly, like you have like hundreds of checkpoints available in Hugging Face, which is like solving very different problems. So what NVIDIA does is like we basically like curate all the open source models, which is like very specifically like famous or useful for the open source fraternity. We make that as a container. So once we make that as a container, it is easier to like consume, deploy, and scale or shrink. So that's the need of NVIDIA inference microservices. So with this form, what happens is you can like deploy this locally in any infrastructure. You need not like go for a managed infrastructure or a serverless form of consumption. So this is going to be purely a Docker container with different forms of deployments, what you can need for your business cases. So, and you also pack this with the industry standard API so that you need not like build and package all these open weights and open parameters for consumption. Then, if you have domain specific code or industry or fine tuning related use cases, then we can also like put that in. Out of it, like what you're trying to achieve here is like we are trying to like improve your throughput and minimize your latency. And whatever GPUs like you are going to like deploy this open source models on top, we are going to like tune that for utmost efficiency and accuracy. So that's the whole point of building a NIM. Just to like give you a bit of technical aspects under the hood, what's happening. So you can see that this is the 10,000 feet view of like what a NIM is. So we basically like use TensorRT LLM package, software package, to like do like things like deep neural network fine tuning or linear algebra related optimizations or in-flight batching kind of capabilities when you are like uh, doing an inference on a large scale Gen AI model. Then based upon the choice of GPUs what you're using, can be like A100s, H100s, or B200s, H200s. We basically optimize these models for the choice and generation of GPU you are operating on top of it. Then if you are like using like a large model like DeepSeek or reasoning models to scale, then you can also we also optimize that for multi GPU deployment or multi node deployment. So these are the nitty gritty things like we do under the hood when we are like building them. Then for consumption side, you can see the left side, like we integrate that with Kubernetes, we integrate that with GPU operators and network operators to like scale it. Then under the hood, whatever Python operations and CUDA operations, we efficiently manage that with the Triton inference server as well. So this is the overall packaging of a NIM, which is going to like run inferences efficiently. Then this is an example of like running a Llama 3 AD instruct model on various GPU architectures. So here you can see that you have like four parameters which you can like optimize for. You can choose a choice of GPU. You can see the number of GPUs like required for running that model. Then you can say that like I want to optimize that with throughput or optimize that with latency or I want to like a balanced endpoint. Then finally, accuracy matters a lot. So you can choose between the kind of precision which you want to like run that model with. So these are the aspects which you can like tune and run that inference engine locally. So these are the engineering effort goes behind like running this kind of inferences at large scale. And this is an example of running a Llama 370B instruct model, which will have different number of GPUs and optimization profiling, so that that specific profile will get loaded into your GPU when you're running that criterion. Right. So we just like touched upon a GenAI model aspect. Then let's talk about the hot topic now, like which is agentic and reasoning. So how agentic AI and reasoning is going to like actually like solve a lot of problems. So why first we need to think about we need to take a step back and think about like why we need agents and why we need reasoning. So if you are going to like use a model as this, then what's going to like happen? You'll have tough times to like do answer validation, or if your questions are like complex and ambiguous, then the model need to like think about it, and it has to like reason back to you and clarify certain questions. Then very important feature is like our thought process can like change, humans thought process or the business flow thought process can change. So the system needs to like handle ambiguity and dynamically adapt to the situation. So for example, if a problem is like being like thought through by the inference engine, then the system may encounter a new information. So it has to like completely redefine the reasoning process, and it has to completely like improve the retrieval process so that the answer synthesis can be like very specific and meaningful. So for these reasons, we are like working at reasoning models. So NVIDIA launched our own reasoning models by fine tuning Llama grade models. So we launched three models, which is in the name of Llama Nemotron family. So this empowers AI agents to tackle complex challenges and adapt to change. So uh, these three sizes will ensure the right fit for any application for delivering optimal performances across systems. So we are looking at highest accuracy for agentic reasoning as well as non-reasoning. So this same endpoint can like help you to achieve both reasoning and non-reasoning promptings. So as well as like you can also like see we can like hit like higher throughput versus leading open reasoning models out there. Right. So just want to like shed some light on like how this flow happens, right? So we start with Llama for its internet scale knowledge and popularity among organizations. Then first thing what we do is we prune the model, reduce its size so that we can reduce the latency and increase the throughput. So both things will reduce the total cost of running an inference so that we can put the GenAI inferences in everybody's hands. Then the next stage, what you see here is knowledge distillation process. So think about knowledge distillation as gaining knowledge from a teacher model who's like teaching students. So from the original Llama model, we increase the accuracy lost during like pruning, or we'll ensure the better responses by the knowledge distillation process. So once the pruning is like uh, done and we do fine tuning on top of the prune model. So what this is going to like do is like we enhance the core capabilities of chat, mathematical understanding, coding, or instruction following capabilities, so that we can operate better on top of reasoning as well as non-reasoning. And NVIDIA also like went through and create synthetic data from open models and public data sets to like do this fine tuning. And then we will also like add reasoning skills on top of it so that we can enhance the scientific thinking capability, math thinking capability, and coding thinking capability, so that we inherit the knowledge of public data set and increase the capability of reasoning. Then the model is further optimized through reinforcement learning capabilities to improve the alignment with user intentions and expectations. So these are the stages of or the recipe of making a reasoning model from available data sets or model weights. Right. So through this process of creating NIM, we don't only look at text generation. So we also look at multiple different domains. Something like you have multi-modality capable models. You have like digital human avatar generating models. You have like simulation models. Something like you have any route optimization problems or any portfolio management problems, or you're looking at weather simulations. So we have models very specifically built for that domain as well. And you have retrieval models. So we work with every open source player out there in the market to like bring these models with utmost efficiency and performance. Right. So this is all about inference I want to like share. Next, what I want to talk about is specifically the Nemo framework. Right. So previously I was talking about Nemo framework. A workflow for the entire Gen AI, right? So that is possible with Nemo framework. So you can like build generative AI or agentic AI applications at scale with Nemo, and this is open source as well. So you can see the total source code in GitHub, and you can also customize the total process under the hood. So let's take a look at very specific aspects of this framework. So the first thing which I want to talk about is everything with Gen AI starts with data. Like you have now you have like data like in the forms of text. You have data in the forms of audio, video, images. So the data curation of Nemo helps you to like specifically curate the data, and the curated information can be like passed through the further stages. So you can like do deduplication, you can do like uh, classification within the data. Assume that like you're like specifically building a stem based model, so you need like specifically filter and heuristically check the data which is stem related. So all these capabilities are easily available with data curation. Then you have image processing pipelines, and you also have video processing pipelines, which I haven't like shown you here. Then the next capability which I want to specifically touch point is the support for tensor parallelism, pipeline parallelism, and expert parallelism. So when you're like going to like build models at large scale or fine-tune models at large scale, your framework has to be capable enough to like scale across multiple GPUs or multiple nodes, and it actually like efficiently use the compute, and it also have like reduce the memory consumption. So Nemo framework has all these capabilities built in, so that you need not like write a lot of complex code when you want to like train do a large scale pre-training or small scale fine tuning. Next, I want to touch upon some basic customization tooling support in Nemo. So customization in the sense I'm specifically talking about fine tuning options. So prompt engineering is just like telling the right information as question. So which is like pretty rudimentary and straightforward. Certain models may take it easy and operate on top of a proper prompt engineered question. The next stage will be like prompt learning. So uh, we can basically curate a very specific task and feed that task to the model, so that like we can like create a simple LSTM model on top of a large scale Gen AI model, so that the LSTM model can act as a gate. Then the questions can be like formulated properly before passing that prompt back to the model itself, the Gen AI model itself. Then you have advanced capabilities like parameter efficient fine tuning and full fledged supervised fine tuning. So you all these different facets of customization is possible with Nemo framework. So you have all the recipes and scripts already built in. All you need to do is you need to get the data. You need to like curate it. Then once the curation is over, you can get those recipes with your base model and start going to like fine tune on top of that the model what you're choosing. Then the next one is like you have advanced techniques support with reinforcement learning. So this is going to like keep up your model with the latest information and feedback what you're like gathering from your business. So that's also, that pipeline is also very much established. And also like you have support for direct preference optimization, proximity preference optimization. So those pipelines and advanced capabilities are also built in. So to get started, to use Nemo, like you can actually like prototype that with GitHub, and also like you have NVIDIA hosted APIs. So you can like go to build.nvidia.com. There you can like see and play around with all the APIs what we have already built with various different verticals. Then if you want to like build uh, custom models from scratch, please take a look at the blogs, so that that's the starting point for you to like go and learn about doing things in a deeper space. Then yeah, this is what I was talking about. So please experience the models, then start prototyping with the APIs, then deploy the containers in your um, uh, local GPUs. Like example, like Xnode, like what Ashton was uh, explaining to us. So this is going to be easy, so that we need not like directly use a managed service. Instead of that, we can control your entire pipeline of Gen AI or agentic AI solutions. To apply for Inception program, you can actually like go to nvidia.com/startups. So there you can like specifically see how Nvidia can help your startup journey. Also, like you can like take a look at our GDC toolkits, SDKs, and technical help by signing up in developer.nvidia.com. So we curate all the latest information, what's happening in the world of Gen AI and agentic AI there, so that you can like learn the latest and greatest things what we're like doing. And to reach out, please do ping. This is our emails, so you can actually reach out to us if you're like, if you want to like take your startup and work with NVIDIA. So this is the contacts I'm flashing here, emails. Please take a look at it. Thank you. Thanks for your time.